This is called love and philosophy. It's not a word that's said in science much. In a way, with this beyond dichotomy, does it feel completely separate from your science and your life and all of this technology and model building?
Gosh, it's so hard to answer that because first we talked about like creativity and passion. And so at that level, it's definitely part of my life. Just, I mean, when people say like, why are you working so much? But no one says that to like someone playing guitar or writing poetry. They're not like, stop doing it. So at that level, it's infused. But there's like that, maybe like another level of your question, I think that you're getting at of like how you see yourself or reality. And yeah, maybe back to the ants realizing they're ants. And so yeah, that definitely is at play too. Like I feel like when you think about how the brain works or how machine learning systems work and listen to people debate things, start thinking about what's the nature of like every person and myself and like how we actually put together. I think it does turn in on itself. And I'm sure that's probably like what drew a lot of people into these fields is that sort of interest in themselves at some level. But there's another level in which it doesn't. I think some people try to make science everything and kind of replace all other ways of understanding the world and make it all encompassing. So yeah, I definitely don't subscribe to that. So when I say scary, it probably was not a good word to use around AI because I mean, people talk about like existential risks from AI, and I'm more worried about the concerns that are already affecting our lives. Like these models have biases. They're affecting people's lives today because they're being deployed in the world. So it seems like we should focus more on that. When I said scary, I think I was just more maybe astonished would be the right word. It's more that like this thing that wasn't even made to do this task. It's better at predicting neuroscience results, and it's pretty trivial to make it better yet by training it on like 20 years of papers. And so if we could do this now with these pretty limited resources and this whole project too, we just like got in this whole game like less than a year ago. So it's pretty rapid. Like there's just so many obvious follow-ons. Like we talked about combining like humans and machines teaming in the future. And so we actually had some analyses that if you combine a person's predictions and the machine's predictions, it's better than either one or two machines or two people. So that means you could actually combine a person and machine together to get like a better prediction than either one alone.
Hi, Brad. I'm so glad you're here. Thank you for doing this today.
Oh, it's my pleasure. Yeah, thanks so much for having me. I'm really looking forward to it.
Yeah, so first thing I was thinking of is it must be really hard to have invented PageRank 3 years before Google. How do
Oh
you
yeah,
live
it's
with this?
a real burden every day. I'm amazed you saw that. Yeah, I guess I wrote a little blog about it and it's made it into Wikipedia. But yeah, it's funny. Yeah, that's actually where my joy of modeling came. It was a undergraduate project. And I guess to be fair, like a lot of people have had this idea and under different guises, but you know, I was interested in how different elements of basically concepts relate to each other. Like, why is it hard to imagine a bird without wings, but you could imagine it being a different color or something? And so ended up just like how the web is a graph of hyperlinks. So it's like, oh, concepts could be that way too. And I had this background that was kind of mixed up between cognitive science and computer science and neuroscience. And so I was taking some applied math courses and just realized, oh, we could do this iterative computation that converges to the eigenvector with the biggest eigenvalue. And yeah, it's funny. It didn't really get me far though. Like I think that got a second place at the Cognitive Science Society conference for the Moore Prize. But yeah, it was the
Well, too
same
far ahead of your
approach.
time.
Oh yeah, yeah. Still waiting to catch up.
I don't know about that because we're going to talk about BrainGPT, and I think that's actually you're ahead of your time again, but maybe at the right time. But we'll get to that. First, I want to try to understand models, and before we get to large language models and BrainGPT, this very exciting idea. First, let's go back. So, where were you? Were you in Austin?
Yeah, so when I got into two universities as an undergraduate, Brown and MIT, and for various reasons, I went to Brown because you could take whatever you, I don't know if it's still like this, but you could do courses in anything. So it wasn't because I didn't really know what I was doing. I just really had an interest that spanned different fields. And I think a lot of people are this way. So yeah, it really gave me the freedom to do topics in mathematics and computer science, and then more in cognitive psychology, cognitive science, and a little bit of neuroscience. And yeah, I always had that split. And I had advisors both in computer science and cognitive science. And I knew I wanted to go to graduate school because I really liked doing research. And that back then, that was the way you do it. Maybe there's other paths now. But when I talked
This
to my
was like in the
advisor,
90s or so, or when?
yeah,
Yeah.
like literally last century. Yeah, and it was a really different world, like intellectually, because topics and I mean, maybe like neuroscience, cognitive science has changed a bit, but machine learning, computer science has changed tons. And in some ways, it wasn't as interesting back then. So there was a lot of like good formal work on like, was it like pack learning? And it was like the rage was like support vector machines, and Bayesian networks were just starting to get popular. So there wasn't
Oh,
really
wow.
this like deep learning work. There was work, connections work was kind of out of favor. But to me, the really critical thing was you couldn't like make models in computer science world that process naturalistic stimuli. And so like all these like core problems in cognitive science about representation and how we construe the world, you couldn't really like solve them. And I mean, it just didn't seem like it was set up to make tons of progress. Anyway, so like, I talked to my advisor, and I don't know if this is the best advice, and it probably doesn't apply at all now because the world's different. But it was like, well, if you want to do science and learn about the mind and brain, you should go get a PhD in psychology. If you want to like make clever machines that do amazing things, go into computer science. And so it's sort of framed as like science versus engineering. And I think we're beyond that dichotomy, but that split. But yeah, I went
Nice.
the science route, but kind of kept up with trying to keep like relevant skills and computation and work in that area because my interests really have never changed since I've been 18 years old.
What
It's
was
just
it? Tell me, like, what was the 18-year-old? I mean, I think you've said somewhere that you wanted to understand how the human mind did problem solving, or you wanted to understand the human mind, but is that like too broad? What was driving you back
yeah,
then?
I mean, yeah, I don't know if it was anything like super deep, but it was just like most people that just spend too much time thinking about weird things. I was always like, how do we construct reality? Almost these questions that are philosophical questions, but thinking, oh, in some angle, you could make some, perhaps make progress on some of these through scientific means and computational studies. And so, I mean, that just really interests me, and just the general idea of how you could have, I mean, this isn't really that reflected in my research, but how you could have a bunch of small interacting elements that could give rise to something more interesting, and that has an aggregate behavior of interest. So whether it's like, I mean, so things that I quickly lost interest in it, but like economics is kind of like that. You have a bunch of people and then you get an iPhone out of it, or products, but the brain's like that too.
What were
So
you
I just,
thinking about when you were a kid or when you were a teenager?
yeah, I mean,
Yeah.
gosh,
Was it
yeah,
like
I
birds
mean,
flocking, or was it books you were reading? Were you in sci-fi? What was going on in your con?
yeah. I mean, I should have a really exciting origin story all queued up for you,
You
but
don't have to.
yeah,
I just wonder if
no, I
what
mean, I
got you
think just,
interested.
I mean, it's probably like a lot of people probably had this same epiphany as a child. Like, I mean, the most basic thing that there's reality, and then there's what I perceive, and that like I'm making it at some level, and just like even though it doesn't feel like that, I'm a biological machine from some perspective that one could take. And there's just like, how the heck does that work? And just because I mean, it's kind of like this the core of like one's being. It's like a whole different like perspective that we don't doesn't feel like that way to us, but from like some perspective that obviously is true. So yeah, I mean, sorry, I'm talking about this in a very childlike way because you asked me this is sort
No,
of
I think
like
it's good. You're
as a
reminding me
like an
like when I was
8-year-old,
a
just
kid
like,
too, how
yeah,
there's
exactly,
these moments where you kind of think like, how is this possible? Actually, for me, you just reminded
yeah.
me, it was my grandmother passed away, which was very sad. But it was the first time I realized, oh, we're like beings in the world creating something and then we're not. And it was kind of this, how does that work? I don't know.
Yeah,
Yeah.
yeah.
I guess kids
It's fun.
come at it many different ways.
Oh yeah, definitely. I mean, it's just obvious like lesson, but still, even as a like young adult, I'm still getting hit with by that. Like maybe I should tell this story, but like when I was an undergraduate, I had a friend that was a medical student, and I can't believe I'm telling the story. Like she snuck me into like where all the cadavers were that they work on. And just I thought it would be super scary. And it kind of was with all these like instruments on the walls to like kind of dissect people and stuff. But like what shocked me was what you're saying, just like there's just like no life there, and just like a kind of like a machine that just sort of like lost its like I don't know, life force or whatever. Not the
Yeah, and you
specific,
kind of go
but
like, what is
yeah,
that?
yeah, exactly. Like, but
Last night
yeah,
I was watching this thing. It just came on
uh,
next. It just played next. And it's a like a hiking trip that goes wrong. The father is buried under the snow. It's a true story. And then the son
oh,
is kind of trying to understand this whole process. But the reason I'm bringing it up is after something like 20 years, they found him under the snow and he was still sort of together, but of course not alive. And I was actually thinking that too. That's so strange that even the body sort of stays the body recognizable for 20 years, but that what you were saying, that life kind of essence isn't there anymore. And yeah, I mean,
yeah,
who knows if we ever figure this out, but it is intriguing from a scientific point of view and from an
yeah.
emotional and personal.
Yeah, no, it's great. Yeah, I'm surprised your questions have taken me back to like my mind like decades ago. Thank you.
But how did you start to think about models? Because you created the sustain model, which I want to get to, which I mean, that's been making waves for decades since last century almost. So like where was that link of the modeling? Because I was interested in these questions. I didn't even understand about modeling and stuff. So were you naturally into computers and coding or I don't know. What were you how did that
Yeah,
happen?
no, yeah, I mean, I think some people get into modeling because they're into like the mathematics and the computers and all that, and like that interests me, but that's not at all why I got into it. It's more I just felt like it was really great for creating scientific understanding, scientific explanations, and just an intuitive things, and just also the interactivity that you could try out different combinations of principles that are like manifested in some computer code that like the code follows from the principles, and you could see how they play out, and like any model, it's like I guess I try things and it wouldn't work, then read some papers, try to identify some empirical phenomena that I thought was relevant, get ideas, look at what other people are doing, and just keep kind of going and iterating, almost like writing a song or something, and then it finally like works, and that it, it yeah, so that's sort of a different way. I mean, I know a lot of people, there's different kinds of modeling. So if you could start to from like a higher level, like computational level, abstract understanding, and then just try to like formalize like what somebody should do. And but I always like models that were more like process algorithmic models that were intended to go through the same steps that we think people do. And so that naturally captures behavior if the model works, but the models also have their own internal representations and components that could be related to other measures that you could get later. Like we did some work using these models to try to make sense of fMRI brain imaging data. So yeah, to me, it felt like just a good way of just kind of knowing what your theory predicts because you're instantiating the principles in something. You could see if you make predictions from it. Sometimes the models surprise you because people like no human's really that smart. So like you put together a few interacting parts and almost anybody could be surprised. Of course, after the fact, you're like, oh, now it makes sense. So you could
Hmm.
trace through and see what's going on. So yeah, I really liked that. I really enjoyed it. And yeah, it just seemed like really creative. So a lot of people don't think science is creative, especially things that are more technical. But I mean, you have like a kind of an infinite, like it's like again, it's like writing a song or a poem. You have like this infinite space of possibilities, and you're trying to do something interesting in it. And
It
yeah,
sounds like the
so
scientific method too, this trial and error, and there's something addictive and rhythmic about it, in a way
yeah.
that also reminds me of music. Were you trying to write songs and play music? I feel like there's some kind of music thing in your
Oh,
life.
it's really fun. Yeah, gosh, I wish I still did, but yeah, I used to live in Austin, Texas,
Whoa.
like 12 and a half years ago. After graduate school, I went to University of Texas to be an assistant professor and left in like 2011. But yeah, I played music there, actually a little bit before, and I maybe it's a little like how I did the modeling. It was all like kind of mostly self-taught, experimental. Like I purposely didn't learn scales or anything.
Hmm.
And so I'm not saying it was good. Probably, hopefully, my modeling's better than that. But it was just sort of like getting out of the comfort zone. Another, yeah. so something, it's basically something creative that was not as analytical, but yeah, I could actually see commonalities even in my own amateurism. Well, the funny part is actually I did get paid money several times to play, which is hilarious because if you're so off the wall, people think it's like you have some deep insight or doing something unusual, and it's just like you just actually don't really
You got
know.
paid to play music in Austin?
Yeah, not a lot,
I
and,
mean, there's so
lots
many
of free
people
drinks.
wanting to be paid to play music in Austin. So what were you doing? Were you like,
Uh,
did you have some
uh,
performance piece or
yeah,
something?
yeah, it was like a kind of like a again, I'm not a very musical person at all, and I think like the academic playing music is kind of almost like cliche I'd like to avoid, but it was basically like an experimental post-punk band with just guitar, sort of singing, and a drummer, and yeah, it was good, but it was like interesting and different, and there was a really good, I mean, I'm sure there still is, but there was really great music scene and lots of little bands playing, and so yeah, I think the pinnacle was like not a big deal, but yeah, like playing. There's this club that's relocated, but like Emos was this classic club on Red River and Sixth Street, and got to getting to play a show there. And this venue
Whoa.
closed down,
I
Beerland,
like how
and
humble you are about all of your accomplishments. I mean, this is something some people would like live on for their life, but okay. But it's great that you bring up this kind of going into areas that you're not comfortable with or something. I wonder if you were doing that when you were doing the sustain model when you were working on it, because here's how I understand it. You tell me if it's not right, but
sure, sure.
I feel like you were doing something that was kind of edgy at that time, or not, maybe edgy in a way that people thought it was too simple even to
Uh,
kind of look at things in this way. I don't feel like you were doing what everyone at that moment would have said is the right orientation. But is that right or not?
yeah, I mean, it's so strange because back then, I mean, you're so right, for maybe a slightly different time period, in my opinion. Like, so at the time, it's hard to imagine now, but modeling was really not very popular at all then. And it was just considered like this kind of boring, pointless thing. It's a lot of time for a lot of communities, I mean, obviously not all. And so from that perspective, from people in psychology, it wouldn't be simple, but then when I started thinking about what these mechanisms might have to do with the hippocampus and prefrontal cortex, then you're totally right, because there was this real split between psychology and neuroscience. There wasn't really like a lot of multi-level thinking. And so like, yeah, it almost like one would have to like ape the details of like, oh, like just exactly what you're saying, they just make something that doesn't really have any clear principles or explanation. They just dump in tons of details that refer to this or that biological detail, or just have some face validity. So like just making a model that, so this is like an incremental clustering model that was really surprised it would make its own sort of representation unit cluster. And I mean, I always saw that, well, of course that could just be, like you can imagine in the brain, just there's a bunch of cells and they're being like kind of recruited into an ensemble. You don't literally have to have like neurogenesis or something. It doesn't have to work like that. But people, I think, in neuroscience really wanted those details. And when something was so simple, like even though it would make good predictions about the time course of like hippocampal activity or representations, and all that work was obviously done with like key collaborators like Ali Preston, Mike Mack, and Tyler Davis and others. But yeah, you're totally right that I think there's a sense still in which people just don't take things seriously that have tons of detail, which is really weird because like the scientific fields at the same time have all this envy, physics envy, and towards these really simple explanations. And you look there, everything is like, yeah, so I really think there's a place to start to have models that are simple, and of course they won't do everything, and then you could expand them. And I mean, you mentioned, I won't go on too long, but you mentioned the flocking work before, and so like a recent model with Rob Mock is trying to make this point that you could take a really simple model, like related to like the sustain model, and you could decompose an aspect of that to create like arbitrary detail for that if you need it for the scientific question of interest. And so I think that could be a good strategy of, instead of getting for explanatory models. I mean, we're going to talk about BrainGPT later, which is totally the opposite. But when you're making a
Mhm.
model as a theory, as an explanation, it's probably not a bad idea to grab the basic components that you're interested in instead of just diving into like the minutia and not really knowing where the explanation is. And then when that model's too simple for accounting for certain phenomena, then you could drill down deeper while still retaining like this higher level understanding of what's going on.
Yeah,
Yeah.
I think we live in these environments that are so rich. I've heard you talk about this before too, and I really like it because you often bring up the context and the situation and the space. And it seems like when you start to look into it, kind of as we were doing when you saw the cadavers, is that the right way to say that word?
Yeah.
Cadaver. Yeah, or when I was talking about with my grandmother, this
Yeah.
it can seem overwhelming. I mean, to try to understand that, it almost seems, of course, this is how people become feeling mystical, and this is why we go to science to try to look into things, and it can seem like everything should be really hard to figure out. So there's a weird blindness there in terms of
Yeah.
starting with a simple model. Also, I have to say it's not that simple. I mean, you had to do a lot of learning, and there's a
Yeah.
whole huge amount of skill set that goes into being able to do something simple. It's again kind of like can be kind of like a song or some kind of art form where it does take a kind of discipline, even if you have a natural talent or whatever. But I want to get into this sustain model a little bit because
Sure.
I think maybe we can unpack some of this stuff. So that's a conceptual model. It's about sort of concept. So I wonder, like, and you're dealing with, I think, prototypes and stuff like this. And for me, trying to understand it, and also people who haven't heard of it, maybe we can explain it. You brought up the hippocampus, and I love the hippocampus. So let's kind of go towards the hippocampus. So if the sustain model, if you're trying to understand something like how we make memories, which I think might have been part of it, right? You can tell me. Then I feel like there's a kind of prototype theory or a way of thinking about like the world as these the body understanding the world through these big categories or chunks, or I think you talk about birds a lot. So there's just big category of birds versus the details where we need every little detail and every little thing. Those are the memories and they're stored somewhere. Or how can you help me understand,
Yeah, yeah,
unpack that?
sure. Yeah, sure. So, I mean, this is really taking back, this is literally like last century, though recently I've done things with this. But
Yeah, I want to move to
there is
that
this sort
too.
of this, yeah, at the time there was these, I mean, other people also did related work, so I would not claim this all for myself, but there's this sort of these two extremes, like you mentioned, in prototype theory. The idea was we just like coalesce all our experiences of some relevant category, like all the birds are represented as one node, and like Eleanor Roche is renowned for popularizing this in the 70s and providing some evidence. And then there's this other extreme of exemplar model where you leave all these traces, and it's sort of like a lazy inference at the time of decision. You activate the model, and that's how you kind of get the abstraction. Yeah, so this model kind of just like a lot of clustering models goes between those extremes, but the key is like when do you how does it work exactly? And so this model basically assumes the world's really simple, and then when it falls on its face and something is some really surprising happens, that throws it off. So yeah, in papers, it talks always use example of like maybe a child being told a bat isn't a bird, and they're like, why? It's small, it flies on its wings, and then you have to do like using the language people do. They talk about the hippocampus as a kind of pattern separation, or if you thought about it as time and event boundary, where you're like basically just that's how you would basically create something almost like an episodic memory at first. So this model kind of says that all these more semantic ideas of like categories come from an initial episode that's just really startling and surprising that sort of anchors it. So if you see, so you would, maybe remember all the details of that first bat you see, but then of course you'd see others and they would intersect with it and become kind of like a bat prototype. And so the model just basically says the world's really simple, but when it surprises you, then you kind of store these details away that could go on into their own regularities. And one thing I like about it, in contrast to, I mean, I'm not anti-Bayesian, even though some people might think that, is that for this model, it really depends on what you're trying to predict, because what's surprising depends on what you're trying to do, what you're paying attention to, basically what you're trying to predict. So it's just not about the structure of the world matters, which people, again, like all the way back to Eleanor Roche have emphasized, but it also matters what you're trying to do in the world, like what your goals are. And so it's kind of like this interaction or play between these two things ends up shaping how you think about things, which could also tie into like even how different languages affect how you think, because they flag up different distinctions, different things you need to predict when you're communicating with people. Yeah,
Yeah.
so I think there's this nice interplay between like you can think of there actually being like information structures in the world, but then they're overlaid with our goals and tasks we have to do. And we come away with maybe like a world model. People use that term a lot in AI in our heads that might be like generative, but it's like really tailored to what we need to do in the world and the kind of predictions we have to make. Yeah.
So we're in the world and we have memories. Like we can just kind of agree on that. We don't need to define
Uh-huh.
it all. And we're trying to understand how they happen. And it makes sense, like from many people, including the way you just presented in the model and Rosh, to think we're somehow there's a lot of regularities. The world comes at us in a very regular way. For the bird and the bat have a lot of things in common. So those are kind of regularities. So it makes sense that we would somehow with our bodies and brains be aligning, fitting to doing something representing these regularities. So the model that you built, the sustain model, is it a way of understanding that process? Like how does it do that? I guess what I'm trying to get at is what is a model really in this cognitive sciences? How are we testing whether that's happening or not?
Yeah. I mean, it's funny when you're asking your question. I was just kind of maybe one reason why this model's worked out well, or why I like it, is it seems like it does a good job. How we actually test it is really like so boring. It's like these lab studies teaching people these novel categories that are so divorced from like human experience and background knowledge. And I've actually kind of fallen out of love with running studies like this because there's just the classic issues of external validity. Is this what you're studying have anything to do with these larger issues? But maybe one reason why like this model's stuck around, or the ideas at least have stuck around, is because like all our discussion has been like these really bigger issues about how you structure your conceptual universe, or how does different languages affect what you think. So if it's a Maya kid in Yucatan, a bat is a bird. So like maybe that affects how you structure your representation. So I think it's like this model, like when you actually evaluate it and lab studies, does a good job, but then it seems like you could still get inspiration to try to understand these things that you don't really apply the model to. We're talking about like these big conceptual issues. And then it was also good to try to make sense of maybe how different systems in the brain support that kind of learning. So yeah, so it's a really interesting question because like, yeah, maybe that's actually what I never really thought about this, but maybe that's what makes something like interesting, at least to me, that it has some actual empirical support in ways that you could carefully kind of poke it and prod it and do like science as usual, good internal validity, but then it could still help shape your thinking about larger issues. And even when I was a kid, like making it was really just was thinking about those larger issues, but at the same time thinking about like a stack of pretty boring psychology papers, behavioral effects that it could pick up as well. So yeah, I guess there was always this duality going on that I never really explicitly thought about until now, but it was definitely going on and part of the process. Maybe it was so implicit that that's how it should be. I never realized to now that that's what I was doing. Yeah.
So I think that makes sense even with the more recent work, which I want to get to too, relative to the hippocampus. But if we think about the hippocampus and memory, so when you were creating this sustained model, and you've done so much more, we don't have to stay on this too long, but just thinking about the hippocampus and thinking about something like concepts and this way that something's happening with the body and brain in terms of recognizing, aligning with these regularities, and then trying to model it inside in the brain, and that helping us to understand the process better. That's kind of one way of coming at, like, if we're trying to understand what the hippocampus does, what memory is, that's a way of coming at it to understand that's how we're remembering, or we're recognizing, we're learning is very connected. And that's a lot of your work too, is that way. But for people who don't know what we're talking about, by concepts and concept learning, do you just mean these big associations, or do you mean something like words? Because I think a lot of people think
Yeah.
concepts are
Oh,
words, you know.
yeah, yeah. And it's funny because yeah, I think people, especially in psychology, cognitive science, neuroscience, like kind of confuse the labels we give for our models and our laboratory tasks with the actual larger, richer thing. And so, yeah, people like when I came into the field doing work in these like category concept learning models, they must have been like, oh, you must be really into conceptual represent this or that. But the way I actually thought about the models was like the things that we call concepts or categories usually just like confabulated with words or labels. And so I just see like more like words as action, or almost maybe like in a Wittgensteinian way, like it's just calling something, like using the bird example, that's just like, that is like an action you have to take. You have to say, call the thing the right thing. Otherwise, people won't like you in your culture if you
Or they won't
start using these
understand
things.
you or
Yeah,
whatever.
exactly.
You
So
won't
that's not the
be, yeah.
concept to me. To me, there really isn't a concept, or there is. It's just to the extent that it is, it's basically just these clusters, these clumps of like useful bundles of information. Or like you say, like there's different ways to partition the world into like basically regularities and clumps. And like we were saying, how you do that will depend on the actual structure of the world, but also how you have to make your way through the world, including like using words in your culture. So yeah, I think of these little regularities that support generalization. So it's all kind of action oriented, even though people wouldn't think of my work that way. I always did. I just thought it turn left or right, say bird or mammal. It's just, these are all just actions you could take, and you try to come up with representations that support those actions. So yeah, so there's not like, so I'm not really like positing any like heavy conceptual machinery, really. It's just to support our behavior, basically, and be able to generalize and make correct inferences.
Yeah, generalization is an important word. And I think people also think of it as like patterns, but I don't know if that's too abstract for you. But this just might get messy and I'll probably try
Sure.
and just edit out some of my stuff, but I really want to
Yeah.
hear your thoughts on it. So when we have ideas, I feel like already back then you were imagining what is becoming more obvious now in the study of the hippocampus, which is that something like memory and something like navigation are kind of the same thing, just
Yeah.
in the same way that when you often talk about it depends on what you're looking for, or it depends on how you've set up the experiment, or it depends on what all this come before. You can't separate what you're looking for and finding and labeling from this whole trajectory of the way the experiment is set up, or where we are in the world, or what the goal is. That, I think a lot of your work shows that in different ways. But the reason I start with sustain and going into the hippocampus is because I feel like the model itself is kind of set up to be agnostic about
Yeah.
all of these labels in a way that's becoming very important now, it feels like. Because
Yeah.
just to give a brief recap, at the time, people thought the hippocampus is all about memory. And then, of course, the place cells, grid cells, border cells had all been labeled, found by this time too. And so it was like, oh, the hippocampus is about navigation. And so there's been this, what is it? The hippocampus is memory, it's knowledge acquisition, it's a GPS, and it all seemed very different. But if you just look at your model and what it's doing, all those things can be the same process, which I gets to later papers that you've done. But I
Oh,
want to
yeah.
throw that out there and see what you think.
No,
Yeah.
no, no. This is not a digression. This is spot on. And yeah, really early on in my thinking, I always saw it exactly that way. Like that is, there's just this one general like learning procedure. And like you said, you could apply it to different domains, things with different labels, uh, different basically subfields in neuroscience. And it's just the same procedure. And yeah, even when I was writing up stuff, I wanted to say this like more strongly, but I thought it's really funny. I noticed one of your guests recently was Lynn Nadell, and
Mhm.
this is years ago, but I was giving a talk at Arizona, I think, where I think he still works there or is
Yeah, he's still
affiliated there.
there.
And I had a personal
Retired, but
meeting
there.
with him. Oh, okay, good. You have more time for fun stuff. And yeah, I brought this up like very sheepishly that, oh, isn't it all this? And I thought I don't know why I thought he would hate it or something, but he's like, oh, no, that totally makes sense. And yeah, I mean, I hope I'm not really, this is decades later. I'm sure what he said was way more subtle, but I just took it as like, I'm not a crazy person. But yeah, but what you're referring
And what were you
to,
saying to him exactly? That
just that,
space is
just
similar to concepts or something?
yeah, that just, it just seems like they're all the same operations of what's going on in these different domains. And yeah, yeah, obviously people know that the hippocampus is implicated in these wildly different on the surface behaviors like in navigation, episodic memory. But yeah, it always seemed that way. And it's just I think Yeah, I think the field got off course because there are things, even from like higher level cognition, when I was starting out, going way back, there's all these ideas that like space is a primitive that structures higher level concepts. And it kind of makes sense. You use language like I'm feeling down today, but there's also cases where it doesn't make sense. Like you're closer to me, I'm closer to you than you are to me. Like doesn't really make sense spatial. But yeah, there's a lot of evidence that that can be true, that we could form representations in one domain, like spatial ones, and apply them to others. I mean, we make analogies all the time. But the question I'm really interested in is what's the machinery under that built those representations in the first place? And I think it really is something like these sort of incremental clustering. And whether you're talking of, there's a whole other dimension that we're not even discussing, which is time. And I think it's the same thing.
Mhm.
Once again, I always saw this way, like in event perception, where why do you segment off an event? It's because something surprising happened. People call it a boundary, but it's just basically like prediction broke down and then you noted it. And then it all just kind of blurred together after that got stored all and wrapped up and integrated into one bundle in your head. But yeah, 100%. So like, yeah, more recent work, like you indicated, has pushed that, saying you could use these same simple clustering mechanisms to look at why you get grid cell responses. And also like you picked up on like very astutely, is that like when you're going to see these kind of responses or not see them, it's like not something it's built in. It's this interplay between the mechanism, the model, and the environment and the task that's going on. So it's, I think it really is all the same. Like not because like I'm just naturally like a bundler as opposed to a separator. I think in this case it's just like, I mean, it's not crazy. There's this brain area. There's these related operations across these domains, and why why shouldn't it be that way?
Yeah, I think
It's,
that goes back to that simplicity that's complicated.
yeah,
Because basically, I think what you've even said, it's a general learning system, which makes sense. And we can use that for what we talk about as memory. We can use it for what we talk about as GPS. I think what gets, is that right? The idea of a
yeah,
general learning?
yeah,
Yeah. But I think what gets hard is, and we should be careful, it's not either or, right? Because I feel like this could be just saying, oh, well, there's no such thing. And in some of your papers too, I wonder about it if you've gotten pushback. It's like saying, okay, we don't really need to, this idea of a concept cell or a place cell or a grid cell. You could almost, and it has almost become clear that we could name cells by almost everything, right? There's cells that fire every time you see Jennifer Aniston, which are called Jennifer Aniston cells, these kind of concept cells, or but actually it's very important that that was found out, and those
yeah,
are very important discoveries, and actually they add to all of this. So it's not an either or, like that we can now understand it, begin to understand it as a general learning system comes from all of that, and it doesn't mean all of that is now not there. It's just that we again kind of zoom out and see it a little bit better, maybe, right? Or
yeah,
broader, or
yeah.
how
I
do you?
mean, yeah. I mean, there's so much to say. I mean, I guess one thing that I never really resonated about, just like discovering cell types or like concept cells, Jennifer Aniston cells, place cells, and so forth. It almost just feels like that's not at all an explanation. It almost like we're talking about being children, and it feels like, because it's going to get me in trouble, but it almost feels like a very childlike view of what science is. Like someone like going through the jungle. Oh, I found a new kind of butterfly, or this, or I went fishing. I mixed a bunch of chemicals together and I discovered something, or eureka. Or like I've been fishing around in brains and I found a cell that does this, so I solved it. Like, I mean, it's other things in science and psychology like that too. Like even the things that look totally the opposite, like the Gibsonian direct perception, always seemed like that. I mean, I really like that in like linking to the environment, ecological psychology, but it's always like, oh, there's no representations. You just know this because there's an environment. I'm like, okay, but something has to compute that and process that. And like just like these cells, you get a cell that lights up when you see Jennifer Aniston. That just, it's not like someone just put that cell in your head. You don't have like a, or you see how the brain's GPS. It's like the brain doesn't have a GPS. Something is computing the stuff and there's things being transformed. I mean, even if you don't take the computational view of the brain, there's a lot of intermediate steps that are leading to that outcome. And to me, that's like the interesting thing to explain how it comes about. Maybe this is like a little too, because you're doing a very good thing of like trying to say, oh, we could integrate all this stuff and everything's valuable, but just to be
No, you should
negative
say what
for
you
a moment.
think. I mean,
Yeah, yeah. It's just it's so like this, yeah, just like a recent paper that's under review now, where it's really actually questioning whether there is a lot of scientific value to identifying these cell types. And this wasn't the kind of process explanatory models that we were discussing earlier. This was really just taking an existing deep learning model and showing that if you put it in the kind of enclosures, we put like rodents in to find these kind of cells in a VR environment and feed it in, you'll basically, even in a random network, you'll see these kinds of cell types, and they look a lot like the ones in the brain. It's not saying they're not real or they don't have value or you have no causal efficacy or that the brain can't have interpretable cells, because I don't think the brain cares about us, what kind of, whether it's interpretable or not interpretable to us. But it's just sort of saying that the discovery alone of these things that might not actually have scientific value because they could come about because it's actually doing what you think it's doing, or it could just come about doing a completely different function as a network. It does something completely unrelated to what you're studying. So that kind of goes back to what I was saying before, to make it more positive, that you need to kind of figure out what the underlying mechanism is and the role of those cells in like a larger computation. And so I think it's like the priorities of science are a bit screwed up, because the discovery, that to me, it's not a discovery. It's just sort of like, it's like finding a butterfly versus understanding how it works or its life cycle or something more. That's like the science. Yeah.
Yeah, I mean, I think we get confused sometimes about a couple of things, I think. I mean, one is that, of course, we want to discover new things, and that can seem like science, where, like with the butterfly, you discover a new species and then you put your name on it or something, you know?
Yeah.
And I think there's something motivating about that that's not bad, but you can go too far to where that becomes the focus. And as you're pointing out, that's actually not, I'm not sure that's going to help the butterflies live longer or be healthier or have a better environment or something. Like, what are we really doing when we talk about
Yeah.
that? We could say that about the brain too, but also, I think if I go back to like the 70s, or when there was all this going on with the hippocampus, with HM, with the first kind of discovery of the place cell, you know, actually, I feel like that was a very important shift in terms of the same thing that your model is helping us understand, which is there are regularities in the world that are, I mean, this is hard because it's not, they don't map to, people always say map to or map onto, but
Uh-huh.
there's a kind of representation or map of it as the body. Like these
Yeah.
things aren't separate. So they're both showing us that there's some really amazing relationship between the way the body and the brain are and the way the
Yeah.
world is as regularities that you can actually study and understand. This is like kind of a
Yeah.
huge
No, I
thing,
think
right?
it's really exciting too. Yeah, I share your passion for
Yeah.
this. Yeah.
So I guess it's, I still see all that discovery, place cells, GPS, memory, HM is really important, but I feel like the story's got to widen a bit. And I think you're being, you would be harsher than I'm being about the importance of that stuff, which is you would have more of a background of how to understand it. But I guess what I'm trying to get at is like, can we just think of this as like a general learning system, and something like Sustain or these models start to help us understand the more nuance we can get, the more the technology gets, can we start to do what I think you've been trying to do? And that's take the context into consideration, take the experiment itself and all the ways it's been developed into consideration, into
Yeah.
the metrics. Can we do that? Does any of this make
Yeah.
sense what I'm
Yeah. I
saying?
mean, I don't want to sound like all negative, because things are progressing, and I think a lot of people are trying to do what you're saying, and it could just be like, so maybe one reason I was seeming more negative is because like labeling these things by like their function almost like shuts down the scientific discussion, because like a lot of what we've been saying, what you just said was about like how the different task contexts affect things, but like the place cell does a lot more, than it's affected by so many things, by reward and they're not, you need to look at the actual, I mean, they're just messier too than they're shown in the paper, like when think how things are actually done. And that's setting aside all the steps that went through and kind of before something ends up being recorded and reported in a paper. But yeah, so but this goes on like all over neuroscience. Like, so, and again, I'm not really against these research areas, but it seems like it's bad to label things by their function, because this kind of assumes we know the answer. So we have, areas in the brain like the fusiform face area, like it shouldn't be called face area, because that sort of like assumes what it does and that the stories over. But and that seems kind of obvious because then you could have like all kinds of debates. Is it really just faces, or is it sort of just fine-grained perceptual distinctions? Is it visual expertise? And so like there's a lot of, that's not my area of research, but there's like a lot of rich questions that would take decades to resolve and subtle things. But in a way, so it shouldn't be called that. The same way, like I don't think it's just semantics either, because you call something a place cell, a grid cell, and this. It's almost like you're just assuming what it is or how it works, and maybe like closing your mind off to like the richer, deeper explanation that will inevitably follow, that is following, but maybe it would come along faster if we didn't have these viewpoints and attitudes towards Eureka, I found this thing or that thing, or
Yeah,
yeah.
and as you're talking, it's also it even if the person who's presenting it doesn't mean for it to be, it becomes that it can only be that thing, which is also not really true about the brain and body. The same cell or group of cells can have many different kind of firing, or let's say names or labels, depending on the context or the way the experiment is set up or what the body's
Yeah,
doing.
yeah, definitely.
Yeah, but to kind of try to go away from the hippocampus a little bit,
Sure,
although
sure.
I could talk about it forever. So what we're trying to think about is how models help us understand being in the world and these things of what mind is and so on. Maybe that's too grandiose. I don't know. You could tell me what you're trying to understand. But there's a many different models. So if we're using it to understand this generalization and patterns learning system, how have you seen models? Because you said at the beginning, right?
Mhm.
These weren't. It wasn't like now. I feel like everything is about modeling, and especially AI. Kind of, we're going to get to
Yeah,
large language models now, and even like everyday people now know what that is, and it's like a huge part of just life. So
yeah,
I'm interested from your perspective what that
sure.
shift has felt like, if you saw it already way back, the way you've seen these things, or yeah, how that's felt.
Yeah, no, I mean, yeah, I want to get on to the new stuff too, but yeah, going all the way back to the graduate school times, I remember just sitting around talking with professors and fellow students, having discussions, because there wasn't any speech recognition that worked. There was no vision systems that worked at all. And we are all like pretty high level cognitive people. In some ways, I was like the lowest level person just trying to make these implemental models. But we sit around like, oh, when do you think we'll have this? When do you think we'll have that? And it'd be like, maybe in 200 years or something. And so, I mean, now I guess just having thought about it and talked with smart people about it way back in the 90s, and now there's these things, they're not perfect, but and there's all kinds of adversarial examples that both for the vision and language models where you could fool them. And I think people like just aren't impressed enough actually, like not with that. The underlying technology is pretty simple, but just how far things have come and how rapidly it has, it's really astonishing. And I think in some ways people focus too much on the shortcomings. And so like even my own research, it's really like opened up doors because I was always interested in learning and representation. But if you just write out what the representation is, like this is a small square and it's blue, like as a feature vector. It's sort of like you skip the hardest problem of how you code this thing up. And not that these models are perfect, but at least you need something to just get in the game to start making them better and iterating, like we discussed earlier. And so, like, yeah, to me, this opened up a whole new world, and but also as a tool too, so that we've been talking about models for explanation to basically implement aspects of theory. But yeah, the BrainGPT project, if we're going to switch over to that, that's not a theory, but it's like a really valuable tool for prediction that can help make theory. So I always see models, even the explanatory ones, where it's maybe even especially the explanatory ones, as offering a kind of compression of theoretical literature. Because if you really understand a model and a model covers a bunch of different studies, it's sort of like a stand-in for those studies. It's like an imperfect like compression of it. Like so if you understood like really simple model like Rescola Wagner's like model of like conditioning, it's not the best model of that area, but you'd probably have like 80% synopsis of like hundreds and hundreds of studies. And so that's like a kind of compression. And we need that more than ever. And that's what got me into the BrainGPT project, because there's just thousands of papers coming out all the time. And it's clear that for certain sciences like neuroscience, that you have to not just look at your own little silo, but integrate information more broadly. So it's just like not really, I'm not sure it's going to be humanly possible, or if it even is now or won't be in the future. It seems like clear already things aren't progressing in science as fast as they could because of this flood of information. So yes, I started just thinking I'm not really a tools person, like for all the things we discussed and talking about childhood. It wasn't like I want to make tools,
Mhm.
but I think this is the future, like whether we like it or not, that it's going to be people and machines teaming together to do science. And so that's one reason that it got me into this project that I'm happy to talk more about. Just
Yeah, let's
um,
connect it to the other
sure,
because as you're talking, I'm thinking these are kind of different models. I think you talk about them as like theoretical or process models, and
yeah,
then
exactly.
Brain GPT is more what like an analytic model. Is that the term you use?
Yeah,
Or
yeah,
yeah.
I think just like a tool. So like all the models we discussed previously have been intended to go through the same steps people do to basically be like there's like some principles of theory, and then you turn that into equations so that you could capture aspects of the theory and evaluate it and see how well it does with actual data and make predictions. So it's really kind of like, and it does the actual task. So if we're making a learning model, it learns stuff like hopefully like people, and forgets stuff and makes mistakes. Whereas you can have other models, and there's tons of neuroscience. Like the example I've been using in talks is like the mind reading, brain decoding, where you have someone say in a brain scanner fMRI, and you want to know if they're looking at cats or shoes. And so you put this classifier on it, and it could be an artificial neural network too, and it predicts whether the person's looking at an image of a cat or a shoe. But that's not a model of object recognition. It's just a tool to help you characterize the information available in those brain voxels. So that's very different than someone saying this is how people recognize objects, and how you would evaluate the model would be totally different. So yeah,
So
using
where's Brain
the
GPT fit in?
yeah, the brain GPT is completely just a tool. So there's no science in it. It's not intended at all to have anything to do with how people, it might have something to do, but it's not intended at all to have anything to do with how people predict things about neuroscience or how the brain works. But what we're interested in is, can we actually predict results from neuroscience studies from methods? Because if you're going to automate any aspects of scientific discovery, that seems like a prerequisite, that if you're like, ooh, should I run this study or that study, or how should I design the study, or you need to have the ability to know, if I do this, this will probably happen, and maybe like put some probability on it. So something like that would be a really valuable tool to help direct scientists' empirical investigations.
Yeah,
And
let's unpack a couple of
yeah,
things first, just for people.
sure,
Because, okay, let me just be kind of
sure.
stupid for a minute. So, those models we were talking about before, they seem magical, right? Because they learn the way that the body and brain are aligned with the regularities of whatever experiment is going on. And then after they kind of learn that, you can use them to see how the brain is going to react in terms of blood flow or something like an fMRI.
Yeah,
And that seems really astounding to people. That's kind of one thing. And then you have these large language models now, right? Which maybe you can even explain a little bit, just,
sure.
what that is. But that also seems really astounding for a very similar reason in a way, even though I see why you're saying these are different, and they are. But it seems like something like OpenAI or the Chat GPT can do the same thing, right? It can read the regularities and go ahead and show you what a person would do. But it's different, right? Because it's actually more forecasting or predicting or something, but maybe you can
Yeah,
better
yeah,
explain
no,
that.
I mean, I think you said it beautifully. Like, yeah, so the really simple models before we discussed, they're intended to go through the same steps as people. They're really models of people, but of course, these models from OpenAI, these large transformer models, they're trained mostly on more text than any human would ever see in 1,000 lifetimes, and they're trained autoregressively, mostly just to predict the next word in a sequence, and with a little extra tweaks to make them conversational. Yeah, they distill these patterns of human experience, but they're probably doing that in a way that's only distantly related to how we make sense of things and learn and whatnot.
It seems like
But
it's accelerated whatever we're doing to some
yeah,
crazy,
yeah, I mean, it's like
crazy speed.
reflecting back I think like the structure of our own knowledge and culture and how we interact with each other. And it's really, I think it's really amazing. But yeah, I think it has a very different flavor, but it could be an incredibly valuable tool. So like a lot of people, this is not what I'm focusing on, but a lot of people are trying to use these to summarize the literature and stuff, make it more tractable. I'm trying to make the literature more tractable, but I kind of think these models are amazing, but have problems when it comes to kind of looking back and summarizing things too. I mean, you and your listeners probably have come across like this term that I don't like, but use like hallucination, where the models make up stuff. They basically confabulate, and it's because they're actually, the models are cool that they're doing this in a way. There are these generative models that seize on the patterns of everything they've been trained on, and so when they like hallucinate, what they're doing is just giving you something that maybe should have happened that didn't. It's almost like when they make up citations of papers,
To like
if they
make
made
up
up a
paper
citation
names
for,
or make up movies or something, and
yeah, but they're
people
like
think
things
they're
that
real.
probably should have existed. Like they're not, like if it's a famous chemist, they're not going to say make up a psychology paper for them. They're going to make up something on their topic that is
Mm.
like almost the triangulation of everything they did. I mean, maybe I'm giving them too much credit, but these things they make up aren't at random. But it's, again, it goes back to generalization. All these models are doing, despite people are obsessed with them memorizing things, but they're really like generalization engines. And to me, that suggests you should use them not to look backwards, but to look forward to predict things. And that's an important part of science on all of it. So that's what we try to focus on in that project is, can we give these basically like a little bit of background and methods and see if the model could predict the correct pattern of results in a neuroscience experiment. And again, that's interesting in and of itself. And it could be good if you're like, want to run a study and say, what are the odds this is going to work out? Like, I think, and if it's 99%, probably you shouldn't run it because it's boring. But if it's like 1%, you probably should run it either, unless you have some deep insight how the whole field and literature has got it wrong, and like why the
Mm.
model's predicting that, and like, yes, this is going to be my high impact paper. But yeah, but I'm thinking about more way into the future for scientific discovery of like helping people design the most informative experiment. And for that, you need to predict the future, basically, which sounds like very like you can't predict the future. Well, you can't really. I mean, it's a stationary distribution. It's the brain's not really changing. There's so many papers being published, so like no real study is really unique. So it's, to me, it's a very minor form of predicting, not to us, but to the model of predicting the future. And it seems very possible and like a
And
way.
it's not only one future, you could predict many, many multiple ones in a way and see
Yeah.
what, yeah, which is
I mean,
fascinating.
yeah, go on. Like, what are you thinking? Please.
Well, I guess I'm thinking about tying this to where we've been too, because so we've been trying to understand learning systems, the body as a learning system, or the body as
Yeah.
being in the world, and there's no choice. You have to learn to survive. You can call it whatever you want to call it if you don't think learning
Yeah.
is the right word, but you have to align with these regularities and deal with them at all these levels. And that's become, as you were pointing out, we've then developed languages, and that's kind of not separate from this. It's part of that
Yeah.
process that we develop the language. And so now, in a weird way, the language has become so important for humans through all these things like papers, where if you're in neuroscience community, you can't, as you've said, it's incredible how many papers are published. Even
Yeah.
on one, like just Hippocampus stuff, you have some talks, which I'll link to, about BrainGPT so people can really dig into it. But
Uh,
you talk about Hippocampus papers, and there's like 20,000 in some small amount of time that are published. I don't know, it's crazy.
yeah.
So now that language is kind of, we're developing objects with that language, papers, all these things that we try to keep up with, and we can't. So we've developed tools to figure out how to do that. And I feel like up till now, it's been about, like, as you were saying, like trying to clarify all that information and give us a little spit out of it. Like, for example, this conversation, I could ask AI, what was this about? It'll tell me a little paragraph of what we talked about. That seems really different from what you're doing with BrainGPT. And it's still hard for me to really understand, but I feel like it's closer to understanding the patterns and the generalizations as already moving us in a certain orientation that we can't keep track of because there's too many possible ones, but maybe AI can help us in a forecasting kind of
Yeah.
way.
No, definitely. I mean, again, all of us are siloed in so many related fields, just use different terms for similar phenomena. And like, I mean, just think of neuroscience, like all the different imaging technology, different species, everything from like DNA to like social behavior. And I don't think it like neatly encapsulates as much as we'd like it to. It's not like a artifact that a human engineered where there's these distinct layers that are separate. Like you said, it's all kind of interacting and information's leaking from one thing to the next thing. And that's probably also going back to a conversation why you shouldn't label a brain area as doing X, because it's going to
Mm-hmm.
be, in reality, it could be more complex than that. And so,
It's all
yeah. So how to,
interdisciplinary, but once you try
yeah,
to hold that information, it becomes so
it's
overwhelming
just
and
not,
impossible.
I don't think it's possible. Like, in like many lifetimes, and even if you had it, just brains aren't, we're just, I just really think we're not built to do this. Like it's just
Not
not,
yet. We need tools. But
yeah, I mean,
that's
it's the
why we get
same.
siloed because we get overwhelmed and we're like, I'm just going to focus
Yeah,
on this particular action potential situation right here. And then we get
yeah,
siloed, even though we're interdisciplinary. So it's always both. Yeah.
yeah, no, it's really, I mean, other things, I mean, it's fine. Like people don't get uncomfortable using a calculator to crunch numbers and
No.
this, but somehow this, I think people feel like this is too intimate, like not being able to predict the outcomes of the experiment. And I think a lot of it, and seeing people's reaction is maybe, this sounds again harsh, but I think people don't realize what being an expert is. It's not really, yes, you should be able to predict something, but it's really, I think more going back to the explanation, understanding the domain and how it's structured. That's can help you make explanations, but I think like a good machine system that can process all the information, maybe it can't give you good explanations right now, maybe in the future it can, but I think it could give you good predictions already, but that's not the same. Yeah, that's like a tool. I mean, it's like, does the calculator have a deep understanding of the structure of mathematics or something? Like, probably
Mhm.
not. But yeah,
It feels too
yeah,
new for us to understand it in that way, maybe that it feels like it's doing our job or something, that we should be able to
yeah,
do that.
yeah. I think it's threatening. Whereas I guess I'm most threatened by being lost in this deluge of papers and
I think that's the
feeling like
real
a bug.
threat. And I think
Was that?
everyone feels it, but
Yeah,
it comes back to why we want to name cells things. And like there's
yeah,
something about science too that we're motivated by our personal contribution, which at the moment still feels like should be being able to predict what the experiment is going to do. But actually, if we could see it a different way, then we might have much more of a role to play if we delegate some of that to the tools.
yeah. No, it takes kind of a maybe a different view of where the value of science lies, and maybe that's yeah going to be difficult. But I think in these messy biological science domains, I mean, whether it's protein folding or neuroscience experiments, I just think we get bigger and better data sets. I mean, I think in the future, these models hopefully won't even be reading the papers. They'll just be like reading the data and the paradigm, because then you probably get even better prediction in some sense, because you wouldn't have this like it's leveraging like human language now, but that's also taking all our biases too. And maybe it would be better to, I mean,
I don't know. I think there's a role for that stuff too, but I see what you're saying. Maybe it would
yeah, there's
clarify.
definitely a role, but it's sort of like I'm just thinking like seeing it in the most like simple terms. If you have like very little like data, then you should have having sort of the bias is helpful because it could guide you and fill in the blanks. But if you have like a lot of data, like how these large language models they are trained on like English and other languages, these models don't really have a lot of biases put into them about the structure of language. And there they thrive because they have so much like more than any human could consume and they could pull it out. So I was just trying to make that analogy to science. If you actually had, of course, the experiments we run aren't at random. So like that's already like I think the most important like human intervention into the system. But if you had tons and tons of data, I mean I wouldn't be surprised if you first we could find out first we could remove the review papers, then you could review then remove. That's all just like our
Right. That
opinion.
is the review in a way that
Yeah,
BrainGPT is reviewing.
yeah, but I don't
But you have to
know.
be
Yeah,
careful, right? In the same way that you said, it's not summarizing it. So,
yeah, yeah. I mean,
but yeah.
I I thought this as a result of predicting results from methods was like really astonishing when we got it. But then I started thinking about just how like neuroscience works, and every time a scientist, including me, publishes a paper, they think it's really insightful and it's like pushing everything ahead and it's a real contribution. How could that be true like 100,000 times a week? Like
I don't
all
know.
these papers being published, like if that were true, why aren't we done in a month, 2 months? Why isn't everything solved? So obviously our papers really aren't, most of them aren't really advances. There has to be so much redundancy and just so many connections between them. And everything has to already, so much has to already be out there, kind of latent, but solved in a
Hmm.
way.
Yeah, we're all so focused on doing this work and fitting it in to wherever little niche we're in that maybe we've kind of lost the vision. It's hard to say, but
Yeah. So, I mean, the fact that this BrainGPT 2 model could predict results from methods probably says like a lot, yeah, about the field. I don't really think it's like some startling technology. It's like good at picking up patterns, and it's been trained on a lot of
Well,
information.
I think you're
Yeah,
being too humble again. So actually this can, I mean, when you hear Brain GPT, it's like Chat GPT or something. And those kind of projects are huge projects that take a lot of money and have taken lifetimes of work and stuff. So how could you, like, for people who don't know what Brain
yeah.
GPT is, like, how in the world did you start this? Like, you're actually close to having a kind of prototype, right? Or some, or
Oh
maybe
no,
you
no,
have it
we have
already.
something you could,
Yeah.
yeah, we have something you could download now. But the short answer is like that ecosystem's really changed in the last few years. So you could build off what other people do. So some, like a lot of papers that come out in cognitive science doing these experiments on GPT-4 or something. So to us, a model like that is completely like, does not have that much value because it's not open source in any sense. So most of these models aren't really open source, but a lot of them are open weights, which means you could download them into like the cloud. So like Microsoft gave us a little bit of money, and you could run them. And so it turns out like these models, without even training them, without spending the millions, you can get really good results in prediction because they're trained on a lot of science. They're trained on all of Wikipedia and stuff. But what we did is we did additional training on 20 years of neuroscience, which is, again, it's not going to be like that much. It was only like, but my memory is bad, but it's probably like 4 modern GPUs running like 80 hours or something. But so this is like within the realm of like a lab could do this easily. And yeah, so that we did that. So we did this fine tuning. I mean, I could go into details if it's of interest, but basically there's this model, like you said, it costs millions to train. But in our case, we took Llama 2 from Meta, and that already does really well at predicting neuroscience results. It's really, really scary. But you could freeze that model. It's 7 billion weights or parameters, and you could train a little pathway off to the side of it to augment it with domain knowledge in neuroscience. And so we just basically just trained on 20 years of neuroscience. And that does a little bit better yet on the benchmark of predicting results. So, but yeah, I guess the amazing thing to me was that these models, even off the shelf, are like better than probably me and most of their colleagues at predicting things. And again, I think it's just because there's just so much that they pick up on these patterns. I mean, I don't doesn't mean they're like smart or experts, but they're really good at predicting things. Yeah.
So you said a minute ago it's kind of scary, and I know you don't really think that large language models, at least as of 5 years ago or 3 years ago or 2 years ago, were that scary. I don't know how you think of it now. You seem to think of it as a tool, and it's going to extend what's possible in a good way, and so on. I want to talk about that a little, and also you mentioned
Sure.
this word benchmark, and I think that's an
Oh,
important word in this project, and the brain bench, or I'm not sure if I get
yeah,
the name.
yeah.
And so I want to hear about those things.
Oh yeah, sure, sure. So when I say scary, it probably was not a good word to use around AI because I mean, there people talk about like existential risks from AI, and like I think like most reasonable people, I'm more worried about the concerns that are already affecting our lives. Like these models have biases. They're affecting people's lives today because they're being deployed in the world. And so yeah, it seems like we should focus more on that. When I said scary, I think I was just more maybe astonished would be the right word. And but it's more that like this thing that wasn't even made to do this task. It was just trained on a bunch of stuff that happened to contain a lot of science stuff. It could just already it's better at predicting things, neuroscience results, and it's pretty trivial to make it better yet by training it on like 20 years of papers. And so if we could do this now with like these pretty limited resources, and this whole project too, we just like got in this whole game like less than a year ago, so it's pretty rapid like progress
The whole
turnaround. It's
game, like,
oh
chat,
of just
because
like
you were
even
doing large language models for a long time, right?
uh no,
Or
actually
no, just
mostly
neural net
language
stuff.
vision models, and yeah, and models because I was interested again in like learning and trying to learn from visual stimuli. So like yeah, I mean I've been playing around with like language models like back before they were any good, like all the way back to the days of like latent semantic analysis. This is like probably did that exist in the late 90s or early 2000s? I think it did, but like so people have been interested in this forever. It's just really a little bit more recent that the results have just as they've scaled up and they switched to this transformer architecture that things have just taken off more. And so like yeah, it just yeah, it just dawned on me. So yeah, so I never really got serious about it or people in my lab until less than a year ago. But the thing is, like, if we're already working with these kind of deep learning models, you kind of it's kind of an easy move into it, and already working with language models in the past. Yeah, so it wasn't that. I mean, I shouldn't say that because if you talk to Shelley and Ken, the first author, be like, oh, it's been a really tough several months of dealing
Yeah.
with
Again, it depends on
TensorFlow.
where you're coming
Yeah,
from.
yeah, exactly.
For you, it was
Yeah,
okay
so
though. It fit to
yeah,
your way of
yeah,
understanding and
exactly. It
learning.
fits into things, and yeah, and I feel like the way we set up the problem too was informed by being a working scientist all those years. Because even talking with some computer science collaborators, they're quite pessimistic on the project and whether it could work, and a number of funders were too. And I think it's because they had a different view of what science is. So I kind of see it like a mess of we each paper by itself isn't that valuable, and all these weak signals that are intermixed. And I think a lot of them, like almost like we're talking about this like naive view of like Eureka, I found the cell, was more like, oh, it's almost this logical deductive process, and you could think through, and the scientist is so smart and everything has a reason. It's a simple explanation. And I think in biological sciences, there's going to be some storytelling that will make us feel good and some actual legitimate explanations, but a lot of it is just going to be, for purposes of prediction, a complete mess, and it's going to involve like 10,000 variables at once coming together that is just never going to make sense, because I think that's what reality, the underlying reality is like. But yeah, sorry, I think you had another question you want to focus on. So that
Well, the
was like
benchmark, but before we get
oh yeah,
there,
the benchmark. Yeah, so
yeah,
bench
that goes back too to this overwhelming, like blooming, buzzing confusion that is the world that we then try to
yeah,
understand. And like there's always this weird kind of in and out between these reduction emergence with neither one of them really ever being right or true. But when you're in one space, you feel like it's true. So like how these scientists probably feel that they're used to a certain way of dealing with the world, and it can seem like that can't be changed by something like BrainGPT. It couldn't help them, but it's really just a scaling up or a different scale, because the same things that are motivating them could motivate them if, I mean, wouldn't it be wonderful if they could just look, they still have the eureka moment if they want and
yeah,
a great idea, but then they can simulate it in a way. It's almost like, let's simulate these many possible ways. And what if I tweak this? What would happen? Or what, to me, this
yeah,
seems
yeah,
brilliant.
exactly. Yeah, I mean, it seems like it'd be a great knowledge discovery tool. You're like, what if I run this fMRI study as an MEG study, or I run it with like elderly people or teenagers, or like what? Yeah, I'm just, and it could be like, because you could get insights, or you could be like, oh my gosh, that prediction is completely wrong. And you could think through why is the model saying this? And you're like, oh, because there's all these papers that use this, have this artifact that they didn't control for this, and so the whole literature is contaminated. And so if I run my paper, you could actually use the model saying like, this model predicts this, but I predict this because of this, and lo and behold, I'm correct. This is a major discovery. And yeah, so I think it could be really useful for directing people's efforts and providing a kind of forward-looking synthesis of the literature. But yeah, like, get to your benchmark question. So like this whole deep learning revolution kicked off really with this AlexNet model of object recognition, and all the that I mean that was huge for the whole world. But even within neuroscience, all the work in computational neuroscience using deep learning and object recognition all kind of followed from that, trying to relate these engineering models to the ventral visual stream. And that's how originally got into deep learning, how I got into deep learning. But yeah, what made that even a discovery was like, how would you know something works or doesn't work? And they had this kind of limited but really good at the time benchmark called ImageNet, and it was just a million images you could train on, and then like 50,000 you could test on that were like held out. So you could say so you train the model to know what a car, an ostrich is, or a bat. And now you show it a new car or a new bat that it's never seen before, and you could see if it could get it right. And so that's how the models are scored. And
Is it, can we
benchmarks
think
could
of
be
it as like a
limiting.
reservoir or something? Or, I mean, how would people think of a benchmark if they've
Oh
never heard
yeah,
this?
yeah. I think it's just like an exam that's like a
Like a
just a,
test of
yeah, exactly, to kind of know where you stand. It's sort of like in the Olympics, we have world records and stuff, and you could measure like how fast someone runs, and that's like you could compare people and see how good they are based on that. It's basically a way of keeping score. And of course, if you have the wrong metric and everybody works to maximize that metric, that could lead the whole field astray. So like
Hmm.
benchmarks can be dangerous in that way, but another way that they're good is it makes everything comparable. So like in science, you want to, not just science engineering, you want to compare different proposals and see which one is the best one, which one does the best job for the accounting for the data. And that's why we compute like model selection statistics and stuff like that. So it's basically like a yardstick just to see which model is the best. And it's objective in that you're just going to get an answer out of it. That's a number. But of course, there's subjectivity into how it was constructed in the first place. But I think it's critical when you're moving into a new area. And like when we're saying, like if we just said these models could predict neuroscience results, and we just gave a couple demonstrations, people wouldn't. I mean, I don't even think people believe it now, but they wouldn't believe it at all. But if we come up with this benchmark of 200 items that were carefully constructed, we show like human experts get 63%, the models get like 80 some percent, then it's like it's a little harder. You have to kind of take it seriously or should figure out what's going on. And when we do additional training of the models, like say on the neuroscience literature, we could say, oh, look, it gets like 3% better. Like training on more neuroscience makes the model better. Or things we discussed before, if we remove the review papers from the training set, we could say, oh no, look, that human insight was important. Now the models are worse. Or is
Mm.
psychology relevant to understanding the brain? Like I think it is. So can we train on a bunch of psychology papers too in the future and see, does that make the predictions better or worse? So it's sort of a way to deal with things that are really nebulous and make them measurable. And I think it's wonderful with the one caveat that benchmark is never going to take into account the whole situation. So if it's not representative of what you really care about, or if people just work to master the benchmark, in some sense, it could be like overfit and self-limiting in that way. Yeah.
So you got a bunch of volunteers or people to help create
Yeah.
all of this? I
Yeah.
mean, that shows there's a lot of interest, right? I mean, that this
Yeah.
within
Oh, it was
itself feels like a very important project, just
Yeah,
creating the
it was
benchmark.
amazing. Yeah, yeah, there was like 75 active volunteers to help make this benchmark because it took tons of human labor just to get it right and do a lot of quality control. And yeah, a lot of the people that contributed are authors on the paper, but other people just helped out a little bit. And yeah, so it's amazing. There was like a waiting list of like 100 people too, because there was just not enough actual work to go around that I could manage that many
Well, that's
people at once.
shows there's a lot of
Yeah,
interest. That's good.
yeah, and there's a lot of interest too for the people. I mean, it's really like kind of tedious to complete the benchmark, but we had over 200 people do it like in a week that the study was open, and so we needed those experts just to see like provide a baseline to compare the models to. And yeah, all that data is publicly available too already if people, the paper's under review, but if people want to play around with the model or human data. Because
Oh,
I think
wow.
it's interesting, apart from just the models, like it's an interesting study of how predictable our field is to scientists within it. And there's a lot of probably nuances in the data that we didn't analyze because our focus was elsewhere. Because I mean, I think that's just an interesting question. Apart from the models, that's really the main story. Yeah.
Yeah, I think it's fascinating and it's really rich. There's probably a lot of potential ways new patterns and generalizations can be noticed using that some way. But I guess it's kind of, I'm going to link to more about GPT, but I want to ask you kind of what you see now, where you are now, what's next. And then I have just a few like quick little questions. Go back to
Sure,
your day.
sure. Yeah, yeah. So like there's just so many like obvious follow-ons from just sticking with the brain GPT,
Yeah, with bench.
like we talked about combining like humans and machines teaming in the future. And so we actually had some analyses that if you combine a person's predictions and the machine's predictions, it's better than either one or two machines or two people. And it's really interesting because there's a, like we talk about diverse teams being good in science, but for prediction, it's really important too, because the models don't see the world the same way as people. They only correlate like 0.16 with how difficult they find items versus human experts. The models and people see things a bit differently in what they find difficult. And the models impressively also know when they're going to make a mistake, just like people do. If they could give their version of confidence and it's higher their confidence, the more likely they are to be correct. And that's true of humans too. So that means you could actually combine a person and a machine together to get like a better prediction than either one alone because they have slightly like non-overlapping knowledge. And so that anyway, that's a really easy thing to do next. And another thing we're doing is we're exploring all different ways of fine-tuning these models to incorporate neuroscience knowledge, because I mean, people are going to want to specialize these for different domains, and we want to make them better than what just comes off the shelf. What's off the shelf is pretty good for a benchmark, but maybe we could even come up with better benchmarks or tougher ones, or just make them even better at ours. So we're looking at all kinds of ways to efficiently train the models.
Or some kind of wiki almost of benchmarking.
Yeah. And then we want to actually try to figure out how to get these models. So you could already download it, but try to figure out how to host it on the web so that we could put some like rudimentary tools up, or if people just want to even chat with it. So we didn't evaluate these models actually in chat mode. We just got like the probabilities out of the weights because it was a little more precise than trying to talk with the thing. But
Gosh, there's
that's
still
the real
so
nature.
much possible. It's
Yeah,
just
yeah, so
beginning.
much. Yeah, yeah. But yeah, the stuff I mentioned before, I think the what I'd like to do, like more in terms of not just weeks or months, but years, is I mean, it sounds out there, but yeah, get into what a lot of people are interested in, automating aspects of scientific discovery. So like really like if you put in a few key questions you're interested in, like does the hippocampus do this? Does it do that? That you can actually use these models and their ability to create hypotheses, but also to evaluate how likely different patterns of data are, to come up with an experiment, like a rough suggestion for an experiment that would actually answer the questions you're interested in. Because I think that's, I mean, to me, that would be like, if people are threatened by prediction, this would be like more, because this is like almost like getting towards like some kind of almost scientific reasoning, creativity. I mean, the model would just be doing this kind of search, but I mean, maybe that's all
Well,
like
maybe it could
maybe a
get
lot of
to a
aspects
point
of
where it's
creativity.
like coding or something, where if you're really specific about what you asked the chat GPT to do, then it does it well. But it doesn't mean you have to know those parameters. So that benchmark becomes really important. But then it could be a kind of aid in creativity, I guess, because the hallucination could become the creativity. It doesn't, because there's
Yeah.
already
I mean,
some potential there of it's doing it, but it's coming up with new stuff. But it's just how do you control that it's coming up with factual, true stuff,
yeah.
new
Well, I
stuff.
guess the great thing about prediction is nothing's factual, so kind of off the hook. Just need something, and it's also the models again. They're already calibrated in their accuracy when they predict something. We get a measure of confidence from the model itself,
There you
and
go.
it kind of knows when its prediction's bad
Right.
or unlikely to be true. So yeah, I think this is the way to use these models, is to, like you said, like they're really, I'm sure everyone's played around with them, but they could write like kind of silly poems and generate all kinds of things. Then you ask them, if you give them something really that's memorized, like who is the president in the US in 1984 or something, it'll get that correct because it's been
Mhm.
like so memorized. But most things
Yeah.
aren't really memorized, and they're just
Hmm.
general patterns shared across weights, and that stuff, it'll just always just make stuff up, or like if it's not attached to another system that like grounds it in some specific source, it'll just I just think it's nature to generalize. So I think it's perfect though for scientific discovery, because there it's not bad. That's what you want, because you want it to try to anticipate what will happen by connecting up all the things that have happened. So yeah, it is kind of creative in that sense. And yeah, so I mean, I think it'd be exciting if there's so many, if you could just write what you care about out, a few statements like, does it do this or that? Then the system would give you probabilities of those, and they could search for the study that would basically reduce your uncertainty about
It
that.
sounds
And
really exciting to me
yeah, I don't know if
because
it'll
it's
ever
like
work, but
it's another one
yeah,
of those leaps, right?
yeah, I
I'm
think
thinking about
it
your
is.
story of sitting in the room
Yeah.
and not being able to imagine 200 years. Like this would be 200 years, 500 years from now. Like right now, that feels like it's happening too. That whatever students are imagining now is probably not close to what might be possible if we
Yeah.
can do this. But you said they a lot, and I do wonder, do you, what do you think? Do you think of them, the AI, the tools?
Oh,
How do you think of them? Are you scared of them at all? And I know we already touched on it a bit, but do you see, not scared,
yeah.
but do you worry that they could be used, that it could get out of control and we can't understand anymore, or have these constraints or parameters for understanding the difference between hallucination and something that's probable? Like if
Oh,
we're going to build
yeah.
a spaceship or something.
Right. Yeah, it's funny because when we put a satellite or try to land something on Mars, that's a prediction, but
Yeah.
it actually works because
Yeah.
it's like
That's true.
direct physics and equations. Yeah. Am I scared? I mean, not not terribly. I mean, I think people need to be responsible. I think the one thing that makes these models like a little bit unpredictable or like difficult to deal with is like a lot of models have like some objective function, something they're trying to maximize. And so you could kind of see what they're doing. And if you put the wrong one, maybe it'll do something bad. And there's all these like ridiculous thought experiments, like the paperclip experiment, like, oh,
Mm-hmm.
make a lot of paper clips and it consumes all the resources on Earth to make it. But that's a little bit ridiculous. But but when you have an objective function, in some sense, it seems like you kind of know what the thing's trying to do, and you could change the objective and make it not do things that are like ridiculously bad. But the large language models don't really have that in a simple way because most of their training is just like autoregressive to predict the next word. And that's not how we use them. We don't use them really. We use them that ask them to predict the result of the study or how to bake a cake or what should I do? Or people probably use them for online therapy or everything. We use
Yeah.
them for all
For me, the large
other,
language models don't seem too scary, but when you start thinking of large action models and large world models, I don't know how
yeah,
plausible you even see those things, but it does start to stretch my brain a bit. Like, wait, what if this kind of capacity could be in all these other realms that aren't conceptual in terms of linguistic? Then I'm not sure what to think about that. What do you think?
yeah. Are you worried about them not performing well or doing bizarre things like edge
I
cases,
just
like
don't know how
how,
to imagine it, what it even is. It's like what's if you're trained on words and generalizing from images and things like this, it seems I can get a grasp on it. But if we make this Internet of Things and everything is sort of
yeah,
all this data is coming in from literally, again, it's the map territory thing where we've made it. If we make a map that fits perfectly to the world, I mean, there's something about
yeah,
that that's already like, is that how? What are we confusing map and territory? Can we do that? But if the world is smart in that way, which people are talking about now with world, world models act so that it's not only language it's trained on, it's somehow training
yeah.
on everything around. I don't know how to get a grasp on that yet.
Yeah, I mean, yeah, in some sense, I'm not surprised these models, even just language, do as well as they do. Because I mean, yeah, I mean, this paper a few years ago in Nature Machine Intelligence with Brett Rhodes, in which we just looked at different spaces, like a linguistic space, a visual space. I think it was like auditory space, like how similar. It turns out that the same patterns like repeat in the different spaces. So like if two objects are visually similar in some way, they tend to also like be talked about the same way. I guess like uh, yeah. Anyway, so you could
It's kind of
kind
a
of
sustained thing, a general learning system, right? It doesn't
yeah,
we don't
yeah,
yeah.
yeah. And so I think the more of these modalities or systems you have that you could sort of, this is what you were hinting at, that you could combine together, probably the truer view you get on the underlying reality. But already, I think even just having language, you're going to get like really far, a lot farther than I think most people thought was possible. But yeah, you're right. The more you incorporate, and of course, we're going to have robots walking around in factories and elsewhere. Like you're going to say there's more. Yeah, I just
Yeah,
don't have
is
my
it a
best thinking.
robot? I mean, I think that's I don't know what the vision is because it is I feel like it's a bit at where you were in that class. Like you couldn't have
Yeah,
really imagined this, but it was happening or it was going to happen. It was already kind of in the works and there's something kind of in the works with all of this, but it's very hard for me to envision what it means if it's something we're
yeah,
wearing on our bodies, if it's an actual robot walking around, if we're just literally interacting with the world. To me, I think about haptics on the phone and how that was unimaginable and then it's just became the
yeah.
most normal thing. I feel like we're in the kind of moment like that in terms of how we interact with our context, but I don't know what it's gonna
Yeah.
be.
Yeah, no, it's really, I mean, yes, some people talk about it like your AI will just be talking to your friend's AIs and like setting up your date for you or something. But I mean, I
Weird.
don't know, because there's other things too. Like, I mean, like people have made a lot of progress on self-driving cars. That's something that has to deal, but then it's not solved, and that's something that has to deal with the complexity of other humans in the real world. And so like there's this like strange thing where there's always these edge cases that might make people not fully trust these things. I mean, a lot of ways, like what's informed this like Brain GPT project is try to think about domains where like a lot of these weaknesses or challenges really don't pose a threat or problem. But this is like obviously like going to change the whole world. So there's thousands of people working on all this stuff. So I mean, hopefully somebody smart will get things a little bit more
Well,
under
I mean,
control.
your
Yeah,
team is already doing something because this could be a
yeah,
template that it doesn't have to, as you say, it's not just brain science. Like if you figure out how to do
no,
this, it actually does start to change. I mean, you can see it scaled and nested, right? Not only would it
yeah,
change different fields, but you could also start to understand how the fields are interacting more. Because for me, what's often very exciting is trying to find connections between all these fields that we don't see already that lead to actual new
yeah.
understandings. That might be more possible with something like this.
No, I know, I think so too. Yeah. So I mean, yeah, I think again, people always focus on the shortcomings of these technologies, but they're going to progress and progress a lot because there's just so much effort and resources being put into it. But even if they don't, I mean, I think it's a lot like in the past where we had the internet and then before that personal computers, and they didn't really change the world like the first 10 years they were around, and they didn't even have that much economic impact and even less social impact and societal impact. And then it's like they just became part of everything. And now it's like hard to imagine the world without the internet or personal computers on our phones now. But so I kind of think even this technology is going to improve so much, even if it doesn't, I think like there's already a revolution in how it's going to affect our lives that's cooked in to the rest of our life. Even if
Mhm.
nothing changed, it's just already going to change
Yeah, part of me
the
thinks it won't
world
be
so
about
much.
robots and cars driving themselves and these kind of so much as somehow the way we connect to one another changing. Like the internet, right? It's not about the
Yeah, we have
computer,
no
it's about the
idea.
internet.
Yeah, we have no idea. Like nobody knew. Like when the internet, I remember like when it started taking off a little, it was like brochures from companies and stuff. Like
Wow.
just being like, oh, we could scan it and put it on. It was like in that, or it was like pets.com Super Bowl ad or something. And now it's everything
Now
is
it's really
I just think it's like yeah, I mean, a lot of everyone's trying to imagine what the future's like, but I think the lesson is it's like people are going to come up with applications and uses, and you mentioned like ways it could go, and that'll be like so much different than what we imagine now, I bet. And like a lot of companies betting billions will just like go out of business because they'll get it wrong. I think it'll be interesting, but it's definitely going to affect our lives, hopefully mostly for the better. But yeah, there's just it's going to be it's going to be interesting and strange. It seems like the pace of change is going to accelerate for both better and worse.
Are you still excited about it? Do you still feel like you want to try to understand how the mind problem solves, or have
Yeah,
you answered that?
yeah. I mean, yeah, I do. There is a little bit of this feeling though of that I didn't have before that gosh, they're really so like the things I say in talks, like I am like internalizing them too. So it's like so I am still trying to do those things, but sometimes I do like feel like a little futility is too strong of a word, but just like, gosh, there really is so much here. And like, I'm doing this and working hard at it. I'm going to continue. But is this something just in 5, 10 years, even that just we're going to just do science in a completely different way and start like automating a lot of these aspects of discovery? And are papers going to be for humans to read even? Like,
Mm-hmm.
will we put them out like findings, or are there just going to be these like massive databases that machines read through? Or like, I mean, usually things don't I say things change and fast and fast and fast, but I mean, look how slow things change in science. Like even the publishing models that just don't make any sense, and we still have them. And we probably will still have them in 5 years. So maybe I'm thinking, maybe I'm getting too far ahead of things. But yeah, I could see the basic practice of science being different. So I'm still developing ideas and pushing things and trying to do explanatory work. But one reason I put so much time into this more predictive tool work is I could just imagine waking up one day and just realizing like why am I even doing this? It's just not how this is like practicing arithmetic when we have calculators.
And by
Yeah.
this, you mean the old kind of.
Oh, like sitting around thinking about how learning or the hippocampus works as opposed to
Mm-hmm.
working with some
Yeah, I'm
machine
really
system
glad you
together.
brought
Yeah.
that up because I think that feeling is something a lot of people start to feel now is like you do, as we were saying, everything is changing and you start to kind of, I don't know, it makes you wonder, how is it worth all the energy you're putting into certain things, which if you're not careful can start to feel like maybe I shouldn't put my energy into anything, which is actually not true. It's just more
Yeah.
shifting it into stuff. I think it goes back to where we started in a way that mystery of still trying to understand what's happening here is still there. and
Yeah,
like connecting with however that motivates you and maybe shifting into another way of exploring that instead of the ways we've been taught we should go. I think that can be really hard and scary. And I
yeah,
do think that's shifting somehow.
yeah. I mean, I definitely don't want people shouldn't be discouraged by a conversation because there's going to be so much to do and like people, everything, there's always going to be a market for like explanation that other humans could understand too, because we just crave that. But I mean, maybe it's just gonna be the natural thing where we just have to give up on some things. Just we already have like machines could go faster than us. They could fly. They could calculate things faster. Like we just no one. I mean, people still play chess even, and they're no good at machines. Crush people at that. I don't
I think
know.
that's true, but we
So
still enjoy it.
yeah, and so yeah, maybe we just have to be open, like you said, like to the change, and it'd be easier said than done. But
Yeah, it's hard
yeah, I
to
don't
feel
really
like
think
you
we
lose
have.
control or something.
Yeah, but I mean, maybe it's off topic, but I don't really think. I mean, we're all like sort of embedded in these huge societies anyway. We're not really in control of much of anything, and everything around me, I can't make myself or like feed myself, and so. I don't know. We're already like ants anyway in a lot of ways.
I
But
think
maybe
we
it's
are,
just
but
the
we're kind of becoming aware of ourselves as ants, and that's
yeah,
something. But in a
yeah,
way, we have to stop thinking of ourselves in the same way too. It's more like maybe we're kind of the ant that's becoming aware of itself as part of the colony, but that's still and that's weird. Like, and that
yeah,
changes the
exactly.
colony.
Yeah, no, 100%. Yeah, so yeah.
I'll just edit that out. I don't know what I'm talking about. But I have, for some reason, I was thinking of this book by Christopher Alexander. Have you ever read it? Pattern Language?
Oh, no, I'm familiar with it, but yeah, but no, I haven't read it.
I
I
was
feel like
wondering.
it's osmosis from yeah, the ideas of that of
Because of
definitely
generalization and the way he talks about it, it's kind of
yeah,
somehow, yeah. And also category theory. Are you in math?
yeah.
Are you interested in that?
Yeah. It's funny. Yeah, I did. I mean, it was so many years ago, but the closest I did to that was abstract algebra with ring theory and this. And just for fun, I just looked at category theory. It just seems like it's sort of the next level of abstracting things away. And you could even study category theory with category theory. And yeah, I mean,
Yeah.
a lot of people seem excited about it and had some discussions on potential projects with it. But yeah, nothing going on with it now. But yeah, why do you bring it up?
Just other conversations I've been having about it reminded me some here of more or less like this forecasting. It might even be more of the benchmark stuff, benchmarking, and that
Yeah.
on that level. When you said you were trying to find a way to get more people involved, it just somehow came up. So I'm just putting it out
No,
there.
no, no. Thank you.
I do have one question, which I can edit out and you don't even have to answer, but this is called Love and Philosophy. So I always at least try to ask, like, that word, it's not a word that's said in science much. In a way, with this beyond dichotomy, I'm trying to push at it a little because I don't know. But I just, when I say it, does it feel completely separate from your science and your life and all this technology and model building? Yeah, I just wonder. I wonder, like, if it just feels like something you bracket off from all of this or if it's infusing it.
Yeah, I mean, gosh, it's so hard to answer that because first we talked about like creativity and passion, and so at that level, it's definitely part of my life. Just like I mean, when people say like, why are you working so much? But like, no one says that to like someone playing guitar or writing poetry. They're not like,
Exactly.
stop doing it. Just like so at that level, it's infused. But there's like that maybe like another level of your question. I think that you're getting at of like how you see yourself or reality and yeah, sort of like it's maybe back to the ants realizing they're ants and so yeah, that definitely is at play too. Like I feel like when you think about how the brain works or how machine learning systems work and listen to people debate things, start thinking about like what's the nature of like every person and myself and like how we actually put together and why do we yeah so yeah I think it does turn in on itself and I'm sure that's probably like what drew a lot of people into these fields is that sort of interest in themselves at some level but there's another level in which it doesn't so I think some people try to make science everything and like kind of replace all other ways of understanding the world and make it all encompassing and Yeah, so yeah, I definitely don't subscribe to that. Maybe like how you have these incompleteness theorems, halting theorems in formal systems. I kind of wonder if there's like a single way to ever that there'll ever be a single way to understand the world and everything in it. I kind of think there won't be. And I think a lot of scientists they think they're being like opening up and being very open about integrating everything together. But to me, it almost seems like it's at some point like one way of thinking or way of gaining knowledge to rule them all. So in that sense, no. But in every other sense, like as a passion, as a perspective on what's going on in myself and other people around me, definitely integrated. So, but maybe not in one way to rule like all experience and understanding and meaning in the world. Yeah.
That's a good answer. When do you ever feel this kind of sense of flow, or I mean, I seem to gather you like music. I mean, you played it well, but it seems to motivate you or make that feeling you have when you, and I don't mean it in a mystical way, but just feeling kind of connected, or even having, like we talked about these eureka moments. And I
Uh,
mean, there's something built into science too, that where you want those moments of transcendence or
yeah.
transformation or feeling at one, I don't know, without getting too like sentimental. But do you ever have that in?
Oh yeah, yeah, no,
Yeah.
definitely. I mean, I think it relates to like feelings of self-efficacy where you put in some work, some time, you think about something and you have like a real insight and maybe it doesn't really matter in the big scheme of things. It could be really esoteric, but you're like, sometimes you're like, wow, like I probably understand this weird little thing better than anybody on earth. But usually when that's true, it doesn't matter because it's like some weird little offshoot of your little super siloed topic. But it is, I think that is like, and it's not just like relative to other people that makes it special. It's more like, yeah, that feeling that you just got somewhere or got something, and now it's like, yeah, like you said, like wonder or flow or transcendence. But it is. It's just like all the because everyone has to deal with so many problems and just so much like BS in day-to-day life, and you're like, ah, that's something that's real that I did, and none of that stuff could screw that up. And I think, yeah, I think that's maybe a way to like when things are going wrong, whatever, to stay a bit happy. Yeah.
Yeah, I think that's really good to bring that up. That's actually a good point. I mean, even doing something like going for a run can give you that kind of like you did something, and I don't
Yeah.
know. And this kind of scales up when you're working like that. And also you do a lot of collaboration. I think that feeling like you're part of a group that's working towards something, and when you see that it's really done, that you've together really created something, there's something about that too.
Oh, yeah, definitely. Like if it's like a peer, it's really great when you affected each other and you kind of see things in a different way that's more compatible. Or if it's someone that's more junior, it's really exciting to see like them grow and get better and better over just a few years. And yeah,
Yeah, because
no,
you have
it's
your own lab now, so you're really, I mean,
yeah,
you've had it a while. We didn't even talk about it, but you have a lot of
yeah,
this going
yeah,
on.
it's cool. Like just seeing people like yeah develop and then go off and do their own things, and yeah, it's good.
Yeah.
And it's like
Well, yeah. Go ahead.
oh no, no. I was
It's
gonna
like
say
a
like
what?
people, yeah, people like make like analogies to like parenthood or something. I don't have kids because and but like it's I think it may so I have no idea, but this happens a lot faster, and it's also like maybe like luckily my parents didn't do this, but some parents make their kids like pursue their passion. But here it's like people are coming to work with you because like they share that same passion. So it seems like
Mm,
it's yeah,
they
it's
find
kind
you.
of a it's kind of an unusual and like rewarding process when it works well and you work with somebody and they develop and get better and better. You have to fulfill their goals, and yeah, it's cool.
Yeah, and you're still pretty young, so you'll see those people go out into the world and do things, and it's quite beautiful, I think. And I don't think that's
Yeah,
going to
no,
change with our technology and AI, that side of all this humanity stuff and science.
yeah, yeah, no, I hope so.
And I
Yeah,
also
I
think
wish to say.
there's a lot of different kinds of reproduction. You know, I've always thought that it's weird that we only focus on, I mean, having children is wonderful, beautiful, but also like we are creating and reproducing things like all the time in all these other fields. And I think it's also like very important in terms of whatever's important in the world for
Yeah.
the world.
Yeah. So we might be ants, but we're strange ants because we could also sort of decide what we value. And
Yeah, I
yeah.
think we're changing what it means to be an ant. Let's just say that.
Yeah. Yeah.
But it depends on the colony, it depends on the context. We're just ants after all, but still there's something happening.
Yeah. No, I'm with you on this.
Thank you so much, Brad. I really, really appreciate your time, and I really appreciate the work you're doing. Truly, like
Wow.
I have for
Thank
many
you.
years. So.
No, it's a real pleasure. Thanks so much for having me, and thanks for your insights. It's really great with all talking about nobody reads things or understands things. It's great to talk with someone who actually has done that, and it's you really like yeah made this time for me. So thank you.
Thank
Yeah,
you. And yeah, I will continue to do so. So, is there
great.
anything that we didn't say or that you want to make sure I put in before we go?
No, gosh, I mean,
It's only been
yeah,
2 hours, so I mean,
yeah. It didn't seem like it. It's funny because I have the kind of personality, especially since the pandemic, where I just can't sit still for a half hour because I just,
yeah.
even when I watch online talks, I usually exercise while doing it. And
Oh wow.
yeah,
I should have
so,
told you you can get up and walk around some. That would have
no,
been
no, I guess
fun.
what I'm saying is I didn't feel that way. For once, I was just like not stir crazy and calm. So yeah, thanks. It must be really good conversation and questions. So yeah, thanks
Well,
so
I really
much.
care about these things, and I really see a lot of value in all the stuff you've done. So it's coming from that place. I think that's the
Well, I
yeah.
mean, this has tremendous value. I mean, this must be, yeah, like you said, I mean, it sounds like you've built up like a really good community around your show and your
It just
channel.
started. I mean, really, it's research. I was just trying to understand things, and someone was like, "Oh, you should
Yeah,
post it because you have such good conversations." And I was like, "Okay." And then, yeah, it just kind of happened. So, but it's what's wonderful is like you were saying too, is just to see how because there's so many little worlds in this world, and it's fun to see those and how they connect, and people really care, and they're really trying to understand the world and connect. And yeah, I find that very beautiful. So that's the best.
yeah,
So anyway, that's all to say thanks for that. I probably needed to
cool.
hear. And any advice because I really don't know what I'm doing.
Yeah, I would solicit advice from everybody, but then maybe not follow it all. Like it's like
Yeah.
that's my advice.
But
To,
isn't it
yeah,
kind of like for you to, I think there's something
yeah,
about the more you put it out there, like with Brain GPT once, like, because
yeah.
this
It
could
kind of
become a
creates like
very big thing. And then that's
yeah,
wonderful, but it comes with a lot, right? Because then you have a lot more people wanting something from you or or
yeah.
criticizing or not,
Oh,
there's a
definitely.
lot more stuff that comes. I guess, yeah, it's back to being ready for it, right?
It's like a series of getting thicker skin or just also just realizing sometimes when people say really nasty things, it's not really about you. It's how people react. And if something gets attention, this is always going to happen. And it's just part of it's just part of how social systems work. And
Yeah, but
it's
it
really
is
hard because
hard.
I
I
try to take
mean, science can be
take
really
it
hard in
apart,
that
but
way. For
it's
me,
not. It's
just
like
staying true to that thing we were talking about, that intention or that what
yeah,
motivates me, because like you said, it's easy to get. I mean, you could get it too, right? That someone comes and wants to buy your ideas and try to turn
yeah,
it, like we'll turn it into a company, and maybe that's the right way, but you could also
yeah.
easily get lost from what's meaningful for you.
Yeah, no, it's really hard trying to figure out what to do next or focus on. Just yeah, just like you're saying. Yeah, I take a lot of long walks just being like, okay, what do I actually really care about, or what's the best
Yeah,
move? And
me
almost
too.
every
Walking is
yeah,
so important.
yeah. No, I used to yeah be completely almost like the really misadjusted. Like, oh, if you're making money off of it, then it can't be your passion. It's like because I grew up in that time where it was still possible to sell out. You talk about like artists selling
That
out.
is
Now it's like,
really that sellout thing is really, I think, detrimental to has been to my mindset a bit. Do you think
yeah,
so? I mean, do you?
I think
Yeah.
it's kind of an outdated notion now. Now it seems like yeah, if I could find something where I could do what I want, do what I believe in, and there was money involved, that would just make it better. Like, I mean, it just seems obvious. It seems like a weird subculture that I grew up in when that was sort of yeah. I mean, that's like even like music, like people would just like stop listening to bands because they sign a major label or something. It doesn't really make sense unless they actually lost control and like their
No, but that
sound
was a
changed. But
big
yeah,
time with that whole Nirvana and
yeah, like so all these things. Yeah,
era
so that was yeah, that was like so it was like everyone was like dumping bands left and right because of them.
selling out.
Yeah, but
It's
it's like kind
curious.
of
I've really thought about it a lot. It's because it affected me too, and
Yeah,
Only recently I feel like I can be healthy and say, okay, money is good and like it's okay to make money as long as it's the attention is like
yeah.
it's
You have
in
to
a
just know,
way
like, your
opening up
box.
scales the way we were talking about earlier of the other
Yeah,
thing.
exactly. Yeah, yeah. It's just like you have to just figure out what your goal is. And I think, I mean, both of our goals are clearly just not to make money. So that's like, I mean, it's kind of simpler if that was the goal, but that's not the goal.
Hmm.
So and the weird thing is sometimes it's not even a trade-off. Like it could just be like the better option for what you want to do
Yeah,
and more
maybe
money.
it's even what you need to do at some point. Maybe that's
Yeah,
been a obstacle.
yeah,
Just
for
let that
something
happen.
sustainable. Yeah, so I don't know. So I wouldn't be scared to go for it. But yeah, but
Yeah, I think that's been a balance because I'm also a little bit restless and always working and thinking and stuff. So I won't make time to create like a set or even put makeup on and look all like that's not going to happen because that is just not me. Anyway, maybe we should go for a walk.
yeah, 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 we should go for a walk. All right. It was really good. It was really nice talking. Yeah,
It
thanks for
was,
doing it.
yeah, it was really great. And good luck with
Yeah,
everything.
yeah, you too. And yeah.
Same to you.
All right, thank you. All right.
All right.
Have a good